Hello, 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 everybody, and welcome back to our very last question, question 25 on the 2007 Pascal competition. Hopefully you've given this a chance. If not, I do encourage you to pause the video and try it for yourself. You can download a copy of the contest, the whole contest, by clicking the very first link in the description. And if you're looking for other solutions, not just mine, because sometimes it takes me a while to do a problem, some nice, neat, concise solutions that can be found at the University of Waterloo website. The only reason that I choose to present my videos rather than just reading off their solutions is because I try and describe my thought process, and I find that can be helpful for you guys out there as you're studying to try and do well on your Pascals. So, let's get into question 25. We've rambled enough. Let's bring on the math. How many 4-digit positive integers x are there, with the property that x and 3x have only even digits? So one such number is 8002. 3x is, and notice that our 3 times x doesn't have to be 4-digit, just our x. So 3x is 24006, and they all only have even digits. Alright. So, if I'm only dealing with even digits, I only have 0, 2, 4, 6, and 8 to work with. And if they're 4-digit, I can never lead with a 0. So those are some things to immediately keep in mind. Now, what happens when we multiply these digits by 3? So 0, 2, 4, 6, and 8. If I were just, that's my digit n. What's 3n? Well, it's going to be 0, 6, 12. I don't like that 1 there. 6 is going to give us 18. Again, I'm not so happy with that 1. And 8 gives us 24. So I like the 24, I like the 6, I like the 0. So I'm liking working with my 0, 2, and my 8. Now, if so these ones have me upset. So if I had something like 24, yes, I know it's not 4-digit, but my point is, if I multiply this by 3, I'm going to get 72. Why am I going to get 72? Well, 3 times 4 is the 12, and sort of this 1 here is going to upset us when we bring the 6 in. The 1 is going to add with any even number. Because notice, if I have 4 and some even number, and I multiply it by 3, I'm going to get 12, and then my even number, 3 times an even number, is still going to be some other, it's going to end even. Some other things might happen, but it's going to end even, and then 1 plus an even is odd. So we're always going to have that problem. So I don't think we can ever use 4. And I don't think we can ever have 6 behind something either. Right, we can't have 6, so you'd have 18. Yeah, that would cause a problem as well. So you can't have anything in front of the 6, I guess. Now, unless there was enough to make these spill over and become 20 is what we carry over. So if I had 4 and some other even number, multiply it by 3, at best I could be carrying over 2. And then we'd have 0, 2, and 1. So that would happen if this was an 8. At best I'm carrying over 2. That's 14. That's not going to be enough. But if I had something like 6 and 8, and I multiply it by 3, the 3 times the 8 gives me 24. Then I get 18. This 2 and this 8 is enough to carry over and give me 20. So, I guess we can never use 4? Because I can't have anything in front of the 4, because we'll always carry over that 1. And nothing behind the 4 will, nothing to the right of the 4 will make it carry over. You'll always be left with that leading 1. So I can never use 4. Alright. if we use a 6, must have an 8 to the right. So 68, that's fine. If I had something like 64, that's not going to work. 62, that's not going to work. 66, that's not going to work. But if I had 668, I'm sort of forming a chain of 6s that have to end in an 8. That'd be 4, 2, and then we'd have 8, 1, and then we'd have 8, 1. So that'd be 4, carry the 1, and that would be fine. Oh, no, that's not a 0, that's an 8. So that would also be a 0, carry the 1. So it don't necessarily need to have an 8 to the right. Our rule is any run or streak of 6s must end in an 8. I don't think there's going to be that many more rules, because otherwise we're seriously constricting ourselves. And look at the count. We're looking at 82, 84, 86. This is a lot of numbers here. So 4 and 6 cause problems. We can never use a 4. You can use 6s, but you have to have some 8s. Or you have to have an 8 after any group of 6. 0s are fine. They can just never be the number we start with. And 2s never cause a problem. Neither do 8s. Okay. So let's break the problem down into 4-digit numbers without 6s, and then 4-digit numbers with 6s. Because the 6s seem to be adding in some problems almost. So without 6s, we can't use a 4, so we can have a 0, 2, or 8. All 3 of those are fair game. We're looking for a 4-digit number. And we can either have a 2 or an 8 for our first digit, and then we have 3 choices for all the other digits. So in total, there's 2 times 3 times 3, so it's going to be 54 of these that don't have 6s. So for example, things like 2,000. I triple that, I get 6,000. Or 8208, which will give me 24,642. So these all work perfectly fine. Now the problem is with the 6s. Alright. So what could we do? So we have 54 of them. That's not bad. We're off to a nice start. So we have to have a 6 somewhere, which means we'll have to have an 8 somewhere. So the question is, where's the 68 going to go? So we could have the 6 and the 8 at the end, and then potentially we have more 6s here. Or we could have a 6 and an 8 here. You can't have a 6 here because you'd need to follow it with an 8. So what would be left? We could have a 0, a 2, or an 8 here. Or you could start with 68, and then again you could have 0, 2, or 8. 0, 2, or 8. Yes, I know we could have a 6 and an 8 here as well, but all right, let's break this down a little bit more. Okay, so the number with 2 different groups of 6 is, so it'd have to have a 68 and a 68. That's fine. That's one of them. There's only one number that works like that. And then what if we had only one group of 68, and we can one group of 6? Okay, we can have a bunch of 6s, but we only have one group of 6s. So we could either have 6, 6, 6, 8. That would be one group of 6. We could have 6, 6, 8 blank. Could have 6, 8 blank blank. We could have blank 668, blank blank 68, and blank 68 blank. I'm a little hesitant here just because I was just thinking of these off the top of my head. I'm trying to write them out in a methodical way. I think that's going to do it. So, with these possibilities, you could have a 0, a 2, or an 8 here, a 0, 2, or an 8 here, or here. You can't have a 0, but you could have a 2 or an 8 here. 2 and an 8, or 0, 2, and 8. 2 and an 8. 0, 2, or an 8. So, this number, I mean, there's only one of those. There's 3 choices here, so there's 3 of the form 6, 6, 8 blank. 3 times 3, there's going to be 9 of these here. 2 of those. 2 times 3 of these. And 2 times 3 of these. Alright, so to recap our calculation, we have 54 4-digit numbers with no 6. We have one that does 6868. That's 2 groups of 6s. We have one with 6668. We have 3 with 668 blank. We have 9 with 6, 8 blank blank. We have 2 with blank 6, 6, 8. We have 6 with blank 6, 8 blank. And we have 6 again with blank blank 6, 8. Alright, so in total, that is, so here's 12 of them, here's another 12, so in total those guys are 24. 2 and 2 is 4, so 24 plus 4 is 28, plus 54 is, ends in a 2, it's going to be 82. Alright, so I'm fairly certain the answer is 82, which I think was A. So I like breaking it down like this. Now these are one group of 6. One group of 6s. The only way that there's more is if I have missed a group. So let's see if we can think through this again logically. I'm only having one group of 6s. So where could my 6 be placed? Let's figure out where the rightmost 6 could be placed. So it could be placed here, or here, or here. So I could have my rightmost 6 placed here, and then I either have it's by itself, or a 6 and a 6, or a 6 and a 6 and a 6. So rightmost 6 is in the 3rd spot. What if my rightmost 6 were in the 2nd spot? Well, I could have just the 6 by itself, or I could have 2 6s. Rightmost is 2nd, and then I could just have the rightmost 6 be in the 1st spot. And so what do those look like with the 8s? That's 6, 8, blank, blank. That's 6, 8, or blank 6, 6, 8. This is 6, 6, 6, 8. There's blanks here. And then this one, it's 8. So that's 1, 2, 3, 4, 5, 6 cases. Did we get all 6 cases? 1, 2, 3, 4, 5. Yep, okay. So I'm confident we've listed them all out. We've got 82 as our answer, and we'll just double check so I don't look foolish. Yes, that is A. It's also the smallest number, which is why I'm a little hesitant, why I wanted to double check that I did work everything out in a nice logical fashion. Yeah, I think that's it. I'm fairly confident we ruled out 4 pretty quickly, and then the 6s and the 8s came together to give us a bunch of them. So, yeah, not a bad question. I don't really have a whole lot to say. It sort of felt like I was just moving from counting case to counting case, and I didn't have a nice methodical way of doing it as I was just sort of running through my possibilities. And you get like that on contests. You absolutely do. You only have an hour to do this stuff. You're not stopping to think and write this up nice and neat and logical. So you do just say, this is a case, this is a case. And you add them all up, and I got 82. And that turns out it's the right answer. But I had some time, so I said, let's stop. Let's make sure I did this in a logical way. No 6s, some 6s. Break the some 6s cases down into there's one run of 6s followed by an 8, and that's it. Or there's 2 runs of 6s followed by 8s, but that can only be 6, 8, 6, 8. So then now we're looking at the one run of 6s followed by an 8. How can that go? There could be a 6, 8 here. There could be a 6, 6, 8, that sort of thing. And I broke those down, and I've justified it to myself that there were only 6 of those subcases. So we're all done. You might have had a completely different approach. Maybe you didn't count the 6s. Maybe you did it some other way. If you did, I would love to hear about it, because I'm always interested to find different ways to do problems. But that's going to close things off for the 2007 Pascal paper. So thanks for joining me for not just this question, but I'm sure you were there for some of the other ones in the past. And yeah. So we'll have the 2008 Pascal. That'll be in the future. Up next will be another grade 9 contest. That'll be the Friar from 2007, but that's a written paper. And if you're looking to try something a little harder, the 2007 Cayley will follow shortly after that. I've been Root Beer. You guys have been wonderful, and I will see you later.